So here's a list of the objectives for the demo if you want to follow along. First, we'll set up our environment, in which case we have two virtual machines. One is the victim, which we'll be attacking, and the other is the host, which we'll be attacking from. We also have to make sure that our victim virtual machine is running the vulnerable version of OpenSSL, since it was obviously patched. Then we will set up our web server on our victim for us to attack, and once our web server is set up, we will attack the web server using a Python script that exploits the Heartbleed bug in OpenSSL. And basically what that Python script does is it sends a heartbeat request of 64 kilobytes with a small payload of hello. And that'll cause the memory to bleed out. Okay, so here I have two VMs. One is the host and one is the victim. So if we go on our victim, open up terminal, we can find out the OpenSSL version, which is 1.0.1. And we know this is vulnerable because if we go online, it'll tell us right here, OpenSSL versions 1.01 through 1.01F, inclusive of vulnerable. So clearly we're running the vulnerable version. And for anyone who wants to follow along in the demo, if you just install this version of Ubuntu, the specific version, it comes pre-installed with the vulnerable version of OpenSSL. And that's what I have here set up for this demo. So now let's set up our web server. We'll start by installing Apache 2. So we use sudo apt get install Apache 2. Enter my password. Click yes. That's all good. We'll go ahead and enable our SSL module. And then we'll enable our website. And then to apply all the configurations we just made, we'll just restart our server, our web server. So to do that, we'll go to etc init and Apache 2. And there we go. So now to check if our web servers are working properly, first I'll get the IP. The IP address right here. So we'll try pinging this from our host. So if you open up terminal on our host, we'll do ping 192.168.25.133. Okay, that seems good. Now let's try opening it up on our host browser. Okay, there we go. So now we'll just try connecting to our web page, https 192.168.25.133, and we'll just still go ahead. And there we go. So the web page works. The web server is up and running. That seems good. Now let's check the connectivity to the HTTPS service using our OpenSSL client. So if I go on my host, we can just type OpenSSL S client connect and the IP address of our victim, 25.133, and then we want to use the HTTPS port. So we're going to type 443. There we go. So this means that the HTTPS service is working properly. We got the certificate here. There was no errors. And so now that we have all that set up, our web server is working perfectly, our 443 port is working properly, our HTTPS port on our web server. So now let's use our Python script right here. We'll use this Python script to exploit the Heartbleed bug on our victim. So basically what the Python script will do is it will send that maliciously crafted payload of just a small message hello, but the payload size will be 64 kilobytes, and that'll cause the memory to bleed out on our victim. So let's go ahead and run that. To run that, we'll just first we have to change directories to our desktop. So we'll do cd desktop, and then we should see the file here. There we go. Now we can use the file heartbleed.py. Then we'll enter the IP address of our victim. 123. And there we go. So we ran the Heartbleed bug on our victim. So as you can see here, this is basically all the memory from our victim on the server. So over here you can see that it's waiting for the hello. First it sent the hello, the small message, then it waited for it, then we got something back, and then this is the heartbeat request that we got back of 64 KB. Left you have the position of the data in hexadecimal. Then in the middle, these rows right here, you have the hexadecimal value of each of those bytes, and then on the right you have the actual real life value that we can decipher in plain text. So clearly over here you can see from this there's not much meaningful data. There's not much we can make out of this data. So let's try this again, and this time let's try to get some sensitive information from our victim. So to do that, I have an HTML file here that I made. It's basically a sample login page. So we'll upload this web page to our Apache web server, and then we'll try to enter a fake username and password, and we'll see if that shows up in the server's memory when we attack it a second time from our host. So I'm just going to fast forward this part because it's not as important to the tutorial. Okay, so now that we have our new web page running on the server, we can try to log in using our new web page. So I'll just open that up. Go to https 192.168.25.133. So here's our sample login page. And then we'll try to enter a fake username and password. So for the username, I can write test123. Password, I'll write test123 as well. And then I'm just going to enter it 2 or 3 more times just to make sure that the server saves it in its memory. So now let's go back to our host and attack the server again with our Python script. Okay, this is the memory from the server, and it's pretty much empty because I just created the VM, so there should be nothing in the memory. But if you scroll up, you can see here there's some more information that we didn't have before. For example, the language was not that important, but right here, you can see the username equals test123 and password equals test123. So you can see that our username and password is showing up in plain text. Now you can imagine if this was a banking website, or if other sensitive information such as the session ID was visible by the hacker, what kind of implications that might have. So that's just a quick demonstration of how Heartbleed can be exploited to retrieve potentially sensitive information from a server. So to recap what we just did, we basically set up a web server on our victim, and then using the vulnerability in OpenSSL, we sent the server a heartbeat request of 64 KB, when in reality our hello message in the Python script was much smaller than 64 KB. The server then sent us back our hello message with the extra information due to our request of 64 KB worth of data. That extra data was the leftover memory of the web server, which happened to include our fake username and password which we entered. This shows that our connection to that web server was vulnerable and open to attacks. Thankfully, during this demo, no real sensitive information was leaked from our server, but you can understand the implications of large corporations that were using OpenSSL or TLS to encrypt the communication between their clients and servers. The very purpose of SSL and TLS is to encrypt the traffic in between clients and servers. But with this bug, a hacker can access all kinds of sensitive information on the server, such as passwords, confidential information, session IDs, cookies, and even things like keys. And you can imagine if a hacker has access to your private keys on your server, they can decipher all future traffic between your server and other servers or clients. And this can all happen without hackers leaving any trace and the user ever getting any indication that their confidential information and or passwords have been compromised. The Heartbleed bug was quickly patched by fixing the payload part of the code. The patch now makes sure that the payload size specified matches the size of the actual message. This prevents the memory from bleeding out and only shows the client what they're supposed to see. So that's pretty much it. I hope you guys learned a little bit about Heartbleed, and thank you for listening.